today. So Chris is a senior SAS consultant at Analytium, and I'm guessing about 20 years of experience working with SAS in data analytics and in various roles, and starting to become a regular presenter at CCP. I think this is maybe number 3 or 4 for him. So yeah, before I hand over to him, I think there's going to be time at the end for questions and answers, but also if you've got any questions you want to chuck into the chat, you can pick them up as we go, or pick them up at the end. So yeah, without further ado, Chris, over to you.
Hi, afternoon. Just first thing first, just check that you can actually hear me, and that you can see some slides.
Yeah.
So yeah, afternoon everyone, welcome. Today I'm going to talk about CASL and how we can use it to access CAS and take advantage of some of the CAS functionality within our SAS code. It's a bit of an extension to the talk I did last time, which was about using CAS, just an introduction to CAS really, but this is more specifically around CASL and how we might use that. So let's go. So a bit of an overview first of all, quick recap. With SASFire, we get our 2 compute engines, traditional SAS compute and the CAS service. The CAS service, Cloud Analytics Service, gives us access to a high performance, massively parallel and memory engine, which can give significant performance improvements over the standard compute engine. It also allows us to use, it has an open API, which allows you to use different routes to access CAS functionality. So you can use open source code to connect via this. You can also use a few other routes as well. So there's multiple routes. Open source code, as I said, using a swap package, you can use Python, R, Lua. SAS Studio dataset code, which is more or less what I was talking about last time. You can also use the tasks within visual analytics and visual statistics that you may be familiar with. But all of those effectively are running on using CASL behind the scenes. They're all, everything translates to CASL to actually operate on the Cloud Analytics server. So what we're talking about here today is actually using it directly. And the reason you might want to do that is it gives you more control and access to functionality that we don't actually get elsewhere. So just to continue the sort of review thing, we'll just have a quick look at the CAS processing. So the CAS server has multiple nodes. It's got a controller node and worker nodes. Client establishes a link to the CAS session. Then data gets loaded into memory from the client side or the server side. Controller node distributes the data across the various nodes. Controller then also distributes the code to the worker node for execution. They will return results to the controller node, and the controller node sends the result data back to the client, and you can then update the data source on disk. So that's kind of the paradigm for it, really. There is an option to be using a sort of an emulation where you just use a single processor where there's not actually multiple nodes, but it sort of pretends it does. But I won't really go into that in any detail. Data storage within CAS is saved in CAS libs, which are defined by CAS lib statements. Only in memory data is actually processed by CAS, so you must load your data to memory before use, and changes made to in-memory tables must be explicitly written back to the data sources to be retained. There are sort of the 2 portions within a CAS lib. There's the in-memory tables, there's a data source section. The data source section is where your files are. In-memory is tables. Data source section is files, which can be physical files, like traditional SAS data sets, CSVs, Excel files, or they can be connection and authentication details to other systems. Multiple routes to load data into CAS. So I think last time we looked at using the data step using CAS lib. So you can link up a CAS lib to a lib name and that we use that for client-side load, so it's loading from the client into the server side. Proc CAS util has various tools for loading the data. Proc CAS, which is what we're looking at today, which is using the table actions, and you have that within that you've got, as I mentioned, you've got client side and server side, which is the different ways of looking at it. You'll see it referred to in the terminology. Client side is external to the CAS server. Server side is on the CAS server. Server side is more efficient, but you need to get your data onto the CAS server in order to do it. So that might require the services of an admin, so it may or may not be available to you. But generally, server side is more efficient because it's actually already on the CAS server. Again, you get more functionality to manage your CAS data within using table actions. So what actually is CASL itself? It's a new language in SAS, so it goes along with all our other ones. So you've got your data, your base data steps and procs. You've got macro, you've got SQL, IML if you know IML, DS2 again if you use it. But I've got another one, CASL. And it's a scripting language used to prepare arguments for execution of CAS actions. You can submit actions to the CAS server and process the action results. Action results are objects, and they can be evaluated, manipulated, and used as arguments for another action. You can also use CASL to create user-defined actions. To access it, you'd use a CAS statement to start your session. So a simple CAS and then a session name, and then use proc CAS to enclose your CASL code and a quit to end it, and then you end your whole session with a CAS terminate, name the session. And this is a fairly straightforward piece of CASL code. So you'll start the CAS session with proc CAS. And then you call a load table action, which does what it says. It's going to load the data into onto the CAS server and load it into memory. You can then, after the slash, you can define a set of parameters. So in this case, we're going to define the path, which is the path for that data set, for that /dat data set. That's the native format for CAS tables, and the name of where we're going to actually push it into memory. You can save the results from those actions as an object. The result object is a variable, so result was X, and you can perform multiple actions which you can chain together. So you can see there we've got the load table, load table, and the simple correlation actions, and they'll happen in sequence. And we just use run statements to submit them, but it's run group processing, so you could have further steps after that, but basically each time you run that, and we'll have a quit to close the CAS connection. Some useful statements for debugging your code within proc CAS. Describe, very useful because it's will print the variable data types to the log, and print, which will print variable values to the log. So that's a little sample there. We're just going to set a variable x equals 3, describe it and print it. And you can see from the log, you can get, it prints out the describe prints out the data type, which here is int64_t, and then you've got a print which will give you the value. Notice the data type is not what you might be familiar with in SAS. It's a int64. We don't normally see that sort of stuff in SAS. We normally have either text, so either character or numeric. So we've got something different going on here. So looking at that in a bit more detail, CASL variables are not the same as SAS variables. A SAS variable is essentially a column in a table, and it's numerical character only. Within CASL, you've got two different types of variables, really. You've got CASL table variables, which are the in-memory table columns, and they can have many data types, including chars, var binary, double, int32, and int64. So we're not, again, it's much more, a lot more data types are available to you than just numeric and character, which does have implications when you're coding. But also we have CASL variables, which we declare in CASL. These are stored in memory and can be referenced in code. They have a similar set of data types, in that you can have numerics and strings and the various types of numerics and strings, but you've also got other ones, including Boolean. You've also got arrays, dictionaries, and tables, and essentially objects. You can declare objects as variables within your CAS code. And we'll come back and have a look at some of the ways we can use some of those different variable types later on. CASL actions are the core of the CAS language, CASL. They're executable routines that perform a single task on the CAS server. They correspond roughly to the interactive tasks in SAS Studio, and they'll usually return result objects. They can return messages, statuses, or performance statistics as well. And the actions are organized into related groups called action sets, which are groups of common actions, and they're usually linked by theme and licensed products. So all VIA installations have access to visual analytics actions. That would include, this isn't a complete list, this is just a sample of some, but built-ins, which enable server management, the tables action set, which allows you to access and manage data and tables, transpose, which does what it says, it transposes data, simple analytics using simple, which allows you to do summary stats, frequencies, simple regression and grouping. And then there are lots of others which are available dependent on licensing. Visual statistics will give you clustering and sampling, non-linear models, just examples of some of them. Visual data mining will give you image processing, machine learning type actions. Look at the documentation for the full details of which ones are available. Some of them quite complicated. But the most interesting ones, the ones we're going to, well, not the most interesting ones, the ones we're going to look at today mostly are around the table actions. And again, it's just a few examples of some of our table actions in here. We've got add CAS lib to add new CAS libs, add table, which obviously adds table, we'll load a table from the client to the server. We've got a load table, which will load a table from a CAS lib data source. Table info and file info, both will list tables or files in a CAS library. Promote, to promote a table to global scope. Fetch, which will retrieve data from a table, and update, which will update rows in the table. So using all of these, we can start to build up some useful functionality. Some of the other, one of the other data types I mentioned, I think I mentioned the array data type, which is an order list of values. We don't, this isn't something you'd have seen normally in SAS. We have arrays, but not as a data type. Created by a fairly straightforward assignment statement, which is comma separated values surrounded by curly brackets. The elements can be numeric or string types, and arrays can hold a mix of types, accessed by position, starting at position 1. Dictionaries are unordered listers of key value pairs, and created by assignment statement again, and dictionary name, curly brackets, and then the key value, key equals, and the value, and as many as you need. And the elements in there are specified by, are accessed by specifying the dictionary and the key. And the reason these, well, one of the reasons these are kind of a fairly interesting and useful is that we can actually, in CASL, we can actually iterate over them. So we can iterate over an array just by doing a do over. So we've got a simple example there of do X over an array and printing out X. So you'll just print out those to the log. Very simple examples these. And a dictionary where you can just do key value over the dictionary, and again you can just print out a list from into the log from a dictionary. And I'll show how we can use that in the demo, which I'm going to do in a bit. We're actually going to go into now. For the demo, I'm just going to do some fairly simple stuff. I'm just going to load some data, summarize it, analyze it, and then we'll output it and save it. So let me just share my right, can you see a SAS session now?
Yeah.
Yeah, cool. Okay. All right. So the first thing I'm going to do is actually just go and show this iterating over a result table. I've got some tables I've already put in, and I'm going to use the table info action and output it to an object called tables, looking at the CAS user library. We're just going to describe, and then I'll describe the object and do a print of it, just so we can have a quick look at that, because I'll show you what we're talking about. And then we're going to iterate over it and drop some tables just to show that how this sort of works. So run that. Hopefully this will. I haven't run it. That's fine. Okay. So looking at the log here of that, you can see my describe has printed out and tells me what it is. So it's a dictionary with that structure, 8 rows, 24 columns, and you can see what comes out with that table info. You get a whole selection of stuff. And then all I've done is iterate over that table, over the table info column, and we'll just delete everything, and we've accessed it by name. So we're just going to pull out all of those and drop those tables using the table drop table action. So that's just showing how you can do an iteration. You could obviously imagine, you could see how you could turn that into doing something. You could actually promote a load of tables, or you could move them to a different different CAS lib. So it's quite a powerful thing. It's basically a bit like having the macro code built into your CAS libs, into your CASL language. Right. So back to the bigger bit of code. And so first of all, in here, I'm going to start my CAS session, and I'm going to assign the CAS lib all assigned. So we'll be able to view all of those within here. So now by using that, I can see CAS user library and the public library. Obviously, you can see the differences in the libraries there. But then I'm going to do a client-side load of some SAS help data. And then load some CSV files using the upload action. You can see we have, this is a tables action, so upload. You don't actually need to use it, the tables, the full tables dot path. You can use it, but you don't need to. And then we've got parameters which are listed as a dictionary, so curly brackets and listed in there. So I'll run that. And I'm also going to then use the simple summary actions to summarize this data, summarize one of the tables, and then use fetch just so we can just view it to see what I've done. So let's run that. So we've taken in some mortality data, which where we've got country and mortality data by country and year and month, and then I summarized it to just give it by year and country, and output it as mortality by country year. Look at the full table. This is a simple summarized table. We use fetch just to bring back a set of data, a subset of data, just to check it, which is quite handy again if you want to debug stuff, or you just want to see that you've done the right thing wrong. Then I'm going to use the alter table action to take some of our tables and alter the details on them. So I've got going to rename some columns in region and keep some columns. Similarly in demographics, just going to sort out the table a little bit, rename some tables, rename some columns, and only keep a few bits. And again for the GDP data, if I run that. It's run okay. If I go and see where would it read, I can see it's got dropped some of the tables and renamed some bits. Now I want to do some joining. I want to join some stuff to join these tables, but and I was going to use some SQL, but you can't really use SQL in directly in CAS because it doesn't really support it except via the fed SQL action. So what we're going to do is we're going to use fed SQL action to submit an SQL query and create a new table, doing some joins. Then I'm going to use the to create a final table which will combine region, GDP, demographic data, and the mortality data into a mortality by region table. Then I'm going to do a correlation, simple correlation, which will generate some correlation data for us by GDP and a couple of demographic data sets. I'm also going to create a version which is grouped by region and output that as a table, and then promote that to public. So just run that. And I managed to get myself an error then. Trying to promote into something which I've already done, so I can't do that. If I check in public. Oh, I have my other tables. So anyway, so you can see there, it's generated some correlation analysis for GDP, for mortality, with more correlating GDP and school percentage. And so that was that, and then I could then promote that, and I'll just clean that up. So that is essentially, let me just. Right, so it should be. So that's kind of a brief overview of how you might do some analysis, well, load some data, do some analysis, and save the data. I guess the question, why would you want to use CAS? Some of the benefits are that it's high performance. So some testing has shown you can get up to a 50% in performance when loading large data volumes. So that's on load. You get similar impact when you're summarizing, analyzing, or performing complex calculations. It's excellent, obviously, for preparing data sets to promote and share for further analysis in CAS and visual analytics. That ability to chain data together is very useful. Why use CAS? Why use CASL rather than just use CASL? You get some improvements in that you don't need to convert from SAS or other code to CASL. And using CASL allows us to make use some of the built-in functionality in CAS, including result objects. And you can easily, as you see, you can easily chain together actions to perform complex data prep. And some functionality like iterating over dictionaries and lists is only really available in CASL. You could emulate it with sort of macro type code, but this is actually sort of native to CAS, so it seems like the best way to do, or a very good way of doing that. SAS's definition, well, not definition, suggestion of when you should use CAS is with large data, which I think they suggested is over 50 gigabytes, or I think 50 gigabytes, which seems quite large. But I've seen testing which says that it actually is quite effective on smaller volumes. They also say when it's computationally intensive, which is kind of quite vague. So I think it's really a case of if you've got large data, seeing when it, and just trying it and seeing whether it's more effective. There's a few things that you shouldn't probably try and do, which is when you need to have order, a particular, or there's need to maintain order within your data sets. CAS doesn't have any native ordering to it. It doesn't understand the order in a data set. So if you run anything which has got ordering, you have to make sure you order it as part of the output. That means it can be inconsistent if you don't do that. So it's not ideal for that. The other issue would be if you're loading loading small data sets, it can be quite inefficient as well, because it will be trying to load them across multiple nodes in small data sets. So actually the overhead can be worse than trying to do it. But as I say, you had to probably just try some of those if in some cases. And I think that is probably it for now. So that's my last slide. So thank you for that. Not sure whether there's any questions on that.
Thanks, Chris. Yeah, I think we've got Reggie's got his hand up. Reggie, feel free to.
Hi there. So a couple of things. So CAS, you mentioned that it's a high performant variable, you can say, variant of SAS. So is it because it's in memory? I mean, what is contributing to this high performance?
It is because it's in memory. It's a cloud. I think CAS. Not sure how familiar with it. If you have visual analytics, you'll have access to it. SAS designed it from the ground up really to be a cloud-based service. So it's in memory. It does. I think it does column-based processing. It's got its own native data storage format, which is the SAS DAT rather than SAS 7B DAT, which is optimized for cloud. And so you've got the whole cloud paradigm effectively of using multiple nodes to process stuff in parallel. Essentially that's why it is. It's SAS's attempt to take, well, SAS is taking us into the world of cloud analytics, really.
Okay, and you mentioned that CAS may not be suitable for smaller chunks of data, but how do you define a big, data volume and a smaller? It's
a difficult question, really, isn't it? I think so. SAS's, I think SAS's suggestion, I think, was I think it was either 50. I can't know. Now I've got myself confused. I can't remember whether it was 50 gig or 50,000 rows, but I think it was 50 gig.
It's 50
So
gig.
50 gig.
I've read that as well. Yeah.
Yeah. But I've seen some work that other people have done, some experimental stuff where they've actually done on much smaller volumes and seen significant improvements. I think the gotcha is when you got a small reference type data set, because it's on nodes, you'll find it has to load those nodes, that small data across multiple nodes. If you're going to say you were doing something to a sort of lookup against a fairly small data set, you have to load that data set across potentially quite a lot of nodes, and that can obviously take a bit of time. So that might be where there may be an issue. I think you probably have to try it out in some cases and just see where it does work and where it doesn't. But certainly bigger data volumes is where it's at. And if you're keeping it all, if you're doing a whole series of processing on CAS, then and not taking it back out, that's where it seems to really be a great advantage. And particularly if you're going to process stuff to use in anything like visual analytics or visual statistics, so if you're generating a big data set that somebody else might use further down the line, that's where it's really going to be helpful, I think.
Okay, and is CAS also monitored using? You had one tool, isn't it? A session monitor. A SAS session monitor was there. You guys had one tool actually, which could be used to monitor SAS. So is CAS also can be integrated?
I'm not sure. Was that on here? You mean on?
Yeah, there is a tool called I think it was called Application Session Monitor, and that can be used to monitor the SAS components. So I was just wondering if this new variant would actually can be configured with that tool, or is it like you need a new plugin or something? So
I'm not sure about that, to be quite honest. But you can monitor performance within CAS. There are various ways of getting performance stats out, which I have to admit I can't remember at the moment. But there are, you can monitor it and you get output stats to the log to test this.
Okay. All right. Yeah. Thanks a lot. Thank you.
Okay. I don't think we've got any other hands up or questions in the chat. So thanks everybody for your time today. Thanks Chris for the presentation. Really good, really interesting. The video will be posted to our channel on YouTube, to our Analytium channel. We'll do that after the call. But for now,